AP Calculus, evaluate the graph of a derivative function, and there's no chance at all that you're going to take the AP exam and not see uh, a question probably on the free response that gives you a graph and asks you to interpret or to draw some conclusions. So this is what that might look like as a sample. It says here the figure below shows the graph of g prime at x, the derivative of function g, and it gives us this domain. So it gives us domain here, and then we're asked to draw some conclusion. It says here, determine the values of x for which g has a relative minimum and a relative maximum. Justify your answers. So this is what I really want to try to drive home to you, is that when you look at a derivative function, this is crucial that you get this. The height of the derivative function, the height of the derivative function is the slope. So even though this function here has a positive slope here, that's not what I'm looking. That's not what I'm looking at. That's not how I'm trying to read this. I'm reading this by its height values. So the height values here are negative height values. They're all in the third quadrant. So they're all. That means my function has a decreasing slope. I don't care where you start. It's still going to have the same effect. So what I'm looking at is this. I go to every place that the derivative function is 0, and it tells me that the slope of my function there is 0. So I'm looking at this, and I draw this invisible wall for myself to look at, and then there's another one right here. Isn't there? And then there's another one right here. So we can start the derivative. We can start the function, graphing the function any place you want, and I think that's the easiest way to do it. I'm going to start. I'll start here. I'll start up here if you don't care. I'll start here. It doesn't matter because from here, if this is x is 3, from here, the function has to be declining. So it's going to decline, 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 decline. By the time I get to this wall where the derivative function has a height of 0, the slope of my function has to be 0. And after that, now I'm going to look at this interval here between these two red lines and say, what's happening with the derivative function, and isn't it true that the derivative function everywhere between here and here has positive heights, and those positive heights tell me that the slope of my function is going to be positive. So I'm going to go up like this, but by the time I get to this red wall, I have to be at a slope of 0 again. So up, 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 up. It doesn't matter. So it doesn't matter where I turn. I just know that by the time I get to this, the slope of the function has got to be 0. So I'm randomly going to choose to turn here. But I could have gone up much farther. It still would have had to slope off, or way down here, but it would have had to slope off to 0 by the time I got to this x value, because the derivative function has a height of 0 here, so the function has to have a slope of 0 there. Now I'm going to look at this next section between these two red walls and see what the heights of my function are. And if you look here, the heights of my derivative function, the heights are all negative down here. Therefore, as you would assume by looking at the graph, it's going to start coming back down. So it comes back down. So it comes back down to here. Look, you can start turning any place you want, but by the time you get to that red wall, the slope has to go off to 0 again. And now it's going to change directions again. And what am I doing? Now I'm looking at the heights of my derivative function. And all these heights, not the slope, not whatever, but all the heights are all in quadrant 1. So they're all positive. So the slope of my function will be positive. Well, look at that. Will be positive. But by the time I get to, look at that, I missed one of those little red walls, didn't I? Because the height of the derivative function is 0 here also, isn't it? So I'm looking, it doesn't matter how I draw it, but what is important, by the time I get to that red wall, whatever height I'm at, that the slope has to go up to 0. So I could do this. I could say, I'd start sloping this thing off to 0 and let this be a slope of 0 right here. All right? So the second one is concavity, and I'm not going to make the concavity argument with you right now, but we could. I'm just going to skip that part if you don't mind right now, and I promise I will come back to it. It says, based on the information given and the fact that g of negative 3 is 3, so this is the point negative 3, 3, and g of 4 is 6. Well, this can't be 6, so I need to redraw this function a little bit, which is no big deal. So if this is 3, 6 might be up here, so I'm going to go up to a height of 6. Remember, though, by the time I get to 4, I have to have a slope of 0. So this is the point 4, 6. And if I was going to continue to graph this, we would probably assume that it would probably fall back off like this and do something like that, because here the slope is 0 again. So this is a possible graph. Could it have started in a different place? In this case, no. Could it have ended in a different place because of the rules they gave us here and here? No. But could these heights have been different? Yeah, they could have been different. But they still would have had to slope to 0 at the specific places that they did. So what is it that I want you to remember? What I really, really want you to take from this, what I think is best for you, if you remember that when we're doing these functions, that the height, if I can say this one more time, the height of the derivative function is the slope of the function. We need not to worry about the slope of the derivative function as it applies to the function itself in this case. So height of the derivative is the slope of the function. So I hope this was really helpful. If you haven't already subscribed, please do. If you have any questions or comments, let me have them. Thanks.